this webinar session, part of the SusFE project. SusFE is a Horizon Europe project funded by the European Commission and aiming at developing innovative solutions for addressing unmet needs in healthcare. And SusFE, as it is highlighted by the nickname of the project, it is Sustainable Flexible Electronics. And this webinar will interrogate sustainability as a driver for the development of new electronics technologies and products. And we'll have 4 speakers, 3 coming from industry, Capitainer, BFC, Pragmatic Semiconductor, and also we will hear the voice of one RTO, Fraunhofer, a German RTO, and well committed to the development of greener, more sustainable solution for electronics. Our first speaker will be Christopher Olin. I will let him introduce him very quickly. Also, some brief housekeeping information. Question can be shared by the chat box anytime, but we'll have first, the 4 lectures from the 4 speakers coming, and to leave some time in the end of the webinar, 10 to 15 minutes, to take the question and to address them by all speakers in a very concise way. And also the question can be raised later if we don't have the time to address all of them. Christopher Olin, Christopher, it is my pleasure to start with you. Share your screen and tell the story about Capitainer and sustainability.
Yeah, thank you. Can you confirm you see my screen?
Yes.
Great. So my name is Christopher Olin, and I am the CEO of Capitainer. I'm going to talk about remote sample collection as a key component in a sustainable healthcare. Challenges in healthcare infrastructure demand loads of blood draws. 70% of all medical decisions are based on laboratory tests. Only in Europe and US, roughly a bit more than 1 billion blood tests is being drawn every year. But 70% of the global population has little or no access to diagnostics. With 30% of the world population suffers from more than one chronic illness. And with an increasing aging population, the rate of chronic illnesses will continue to increase, resulting in a steady growth in demand on number of blood draws. However, the current healthcare infrastructure is not able to meet this coming demand. So that's why Capitainer was formed. And a little bit about Capitainer. We are a SME funded 2016 in Sweden. We are an impact company greatly affecting the environmental and equal care. What we do is we provide products and solutions for clinical sampling for all non-acute needs. And the way we do that is that we are providing a technology platform, giving cost savings, enabling healthcare improvements, and bridging the gap of diagnostics of the future. So, what Capitainer products enable is that a blood sample can be taken by the patient in their home through a finger prick. The blood sample has the same quality as taken by a professional phlebotomist in a healthcare facility. The sample is dried, which means it can be shipped via regular postal mail, removing the need of cold chain transportation to the laboratory. So this is how it works. The patients get a sampling kit sent to their home, including everything they need, like a lancet, plaster, Capitainer cards, etc. You start by disinfecting and picking our finger, apply a few drops of blood to the product, pack it, and ship it back to lab. And there we use it to analyze most common analytes. Not everything is possible, but a big part is possible. So, looking at Capitainer from a sustainability point of view, already when we were founded at the start 2016, we had this mindset within Capitainer. We decided from the very first start that all our products should be able to be shipped with regular post, which means they need to be flat and they need to be lightweight. But we also had a very clear minimize plastic consumption principle. And paper is really the main source of our products. And we only use plastic where it's absolutely necessary. In our case, it's in the microfluids because we need the precision and the exactness of the volume. So now what we started to work with is really our value chain. It's from the research and development, the production, our own facility, including our R&D lab, the caregivers and the end users, the ones using our products. And we have started on ongoing work to create a really strong sustainability plan with very clear goals and actions. So from a sustainability point of view, let's have a look on how we really affect the sustainability development goals in the EU and in the Paris Agreement. And a few of them we have a direct impact on. But the biggest one comes, of course, from the patient benefits. Where accessibility shines, we give the possibility for everyone. You know, our vision is to reach everyone everywhere. And on the convenience side, of course, how to use Capitainer, that you can take the blood draw whenever it's convenient for yourself. You have the time savings. The discretion is actually also a very important one. A lot of the chronic illness and a lot of testing, you don't want other people to know that you're even doing some blood draws and doing some follow-ups. And that also comes to the continuity of care, which is also where our products really makes a big difference for the patients. On the society, on the healthcare benefits, the extended geographical footprints, enabling specialization of laboratories, of medical services, reduced cost on the healthcare, the optimization of the resources. Phlebotomist is one of the really spare resources, as well as the nurses, which are many times used for blood draws. Specifically on the environmental benefits, the eco-friendly materials, effective waste management, reducement of cost, but more than anything is reduction of emission. So let's look a little bit into the future and the SusFE project specifically. Digitalization drives demand for sampling at home. That is something we see in many areas. And even in Sweden, the population screening drives the demand for more blood tests. We just started a project for prostate cancer, and we do it actually up north, where the males many times have several hours drive just to do a blood draw, which means they don't participate in a prostate cancer screening program, which means we're doing this to save life as well as environmental sustainability and all of it. We see a very clear trend of home care. The drives for new type of blood tests, not necessarily more, but it's a very strong trend both in the US as well as in Europe. We have wellness, which many talked about, and it's been in the media a lot. People care more and more about their own health, and they want to know what's happening in them. Another part is definitely the pharma industry, and due to the demand for more clinical trials, pharma has some real challenges. In direct dialogue with one of the large pharma companies, we have learned that the average travel time to a trial site is 2 hours in general in the US. Due to this, they also have a problem with the same individuals are taking part in many trials, which of course is not good. Looking at the future, they need to double the amount of clinical trials they ever done before 2030. And they simply need to find other ways of drawing blood, which is an essential part. So they have specific demands, the digitalization has specific demands, and SusFE project enables next generation self-sampling project. And in SusFE, we are integrating a timestamp using sustainable components. This means integrating electrodes in our microfluids to start a timer in a flexible integrated circuit. We include an RFID tag for wireless readout of time and date in the lab, and it's also powered by an enzymatic fuel cell. And I know that several of those delivering these superb services going to present after me. But for Capitainer, this means an enormous amount to us. It means the rising demands with new demands that we had to meet, and we could easily have done this with normal electronics. But now this SusFE project means we can do it. We developed with a sustainable approach, and we look at the time and date as the first proof of concept. Having the power within the card means we can do other things like geopoint, we can do positioning, temperature. So for us, Capitainer, SusFE made it all possible. We are a small SME. We don't have the resources to do a project like this, and we are very honored to be part of it, and that we were selected for it. So thank you all for listening, and that's all from me. Thank you.
Thank you so much. Once again, don't hesitate to raise questions by using the Q&A. We will take them later in the end of the webinar. We will move to the next speaker, Jules Hamon from BFC. Jules, introduce yourself and keep the time as well to save time for the question at the end of the webinar. Jules, go ahead.
Thank you, Yves. So thank you everyone for attending, and thank you for your continued attention. My name is Jules Hammond. I'm the co-CEO and one of the co-founders at BFC. BFC stands for Bioenzymatic Fuel Cell. We produce a sustainable, compostable energy solution for the next generation of smart and sustainable electronics. So today I want to try to take a fairly solution agnostic approach. I want to prepare and demonstrate the opportunities and challenges that lie ahead for sustainable, flexible electronics. I want to raise the key point of deciding between transient and reusable devices, particularly for the healthcare market, the key life cycle assessment considerations that should be applied, the opportunities in terms of the device stack up, with the energy device from BFC being one of these, and then finally finish with some free tools that other people can use for quick, sustainable assessments. So in terms of opportunities and challenges, we have the enhanced accessibility, as Christopher mentioned, at-home monitoring. There's the miniaturization, as sensors get smaller and it becomes easier to miniaturize the products. There is wearable technology. A lot of people now have smartwatches, but we can also imagine things like smart bandages. This leads to increased comfort, better adherence, so you can collect more data. With more data, we're creating digital ecosystems, so the Internet of Medical Things, producing new insights and enabling early detection. This earlier detection can lead to cost savings, also the fewer hospital visits, as Christopher mentioned, up to 2 hours typically in the US, and that leads to better patient outcomes, and of course, sustainability. In terms of challenges, there's things like standardization, creating too much data and leading to data overload, the power and connectivity where we believe BFC can help, regulatory and compliance, user adoption, because if patients and even clinicians don't adopt the technology, it's frankly useless, the life cycle management, and then misinterpretation and misdiagnostics that can create from unsupervised device usage. If you create millions, not to say billions of devices, you have to be careful with how we're using them. So then an important factor for me is the early choice to be made between transient and reusable. I believe that things need to be fit for purpose. So in terms of transient or single-use devices, they can be convenient because there's no maintenance, no need to calibrate, clean, sterilize before use. You often have lower upfront costs. They can be lightweight, compact. Hygiene is important, again, removing the issue of cross-contamination, and you can have technological agility. In terms of downsides, of course, having disposable devices can contribute to e-waste, and that's where SusFE comes in, because we can drive new material innovation, life cycle design, and look at the recycling programs. There is often a high material and energy per usage for disposable devices, sometimes limited functionality, and then the cost over time can accrue and become more expensive than reusable devices. If we look at reusable, you have extended life cycle that you can offset the upfront cost against, often better durability because of the cost of materials that can be used. Advanced functionality, you can afford more expensive sensors or readout displays. and it could potentially be customizable in terms of repairs or future module upgrades. The downsides, the maintenance, and in the health setting, this is quite important because clinicians, nurses don't want to take the burden of responsibility for cleaning, calibration, and repair. There's the risk of cross-contamination, where the secondary cost can be quite substantial. The upfront cost of reusable devices can be astronomical, and then the obsolescence risk, because the time it takes to develop a product means that by the time it's deployed, it's already out of date. So then moving on to life cycle analysis, one of the key metrics we use to define sustainability. Key points for me is looking at the raw materials that we can use in terms of their sourcing, whether they're renewable or recyclable, the design development to look at the longevity of the product and make sure it's compliant across multi-regions, the manufacturing in terms of energy use, the type of energy, the water usage, as well as any waste and yield metrics, the packaging, because of course, single-use devices can often have a lot of secondary and tertiary packaging. The transportation and distribution, here mass becomes a key factor. The use, how efficacious or efficient the product is, any required maintenance or calibration, the safety, and then of course the patient outcome. Again, coming back to the fit for purpose. The end of life, understanding the recycling streams. Just because you can recycle doesn't mean it will be. The recovery, ease of recovery, if you generate any complex waste, and then the circularity, and then regulatory compliance, social and ethical considerations. Now, I wanted to cover from the electronics point of view the four-step rule. I think a key learning I've had from all of the studies I've performed is that the substrates for the electronics, be it the PCB in fiberglass, is typically the biggest contributor, and this is due to the multi-step production process. Then it's down to large passive components. For instance, coil wound inductors are particularly detrimental to the life cycle assessment. And then integrated circuits, and we'll hear from Pragmatic Semiconductor later about ways to circumvent this, but often ICs have a very high environmental impact with respect to their mass, and this is due to the complex wafer manufacturing steps. So the four-step rule is to first of all look at the type and size of the printed circuit board used in the electronic device, then the number and type of integrated circuits, next the mass, and then finally the precious metals used. So I wanted to explore what we can play with in the sandbox in terms of the device stack-up. So I'll cover PCB substrates, conductive traces, energy devices, and active components. So first of all, here is a table of the four most common materials used in printed circuit board manufacturing. You have FR4, which is fiberglass-based polyimide, or sometimes known under the name of Captain. You have PET, a type of polymer, and then you have paper. Now, the two columns on the right, PET and paper, are great because they can be renewable or biodegradable, and they're either easily or widely recyclable. In terms of environmental impact, it's low to moderate, but unfortunately they have only moderate to limited performance and application scope, which means we have to use these materials just for specific applications. Whereas fiberglass and polyimide have very high performance, broad application scope, but of course don't meet the sustainability metrics we're looking for. So then moving on to the types of materials used in the conductive traces, and the main suspects are copper, silver, carbon, aluminium, and tin. Some of these are suitable for subtractive manufacturing and others for additive. There is a trend today towards using aluminium and tin for traditional circuit board manufacturing or RFID tags, and then silver and carbon and copper for printed electronics on polymers and papers. And they all have their pros and cons, and therefore all aspects of the device design, performance, and sustainability should be considered before selecting one of these materials. And on the photograph, you can see some various examples of printed flexible electronics in copper, silver, and aluminium. I wanted to explain where we can go, and here we have an example of silver ink printed on paper, and studies have shown that the metal part, the silver, can be recovered up to 92% through a process of pulping, vortex cleaning, screening with a mesh, and then flotation to subtract the ink from the paper pulp. And this is really a good indicator of where we could go in the next few years. One of the key challenges and therefore an opportunity is multi-layer PCBs or printed circuit boards when we look at additive or printing technologies. And this slide shows 3 different examples, inkjet, screen printing, as well as stencil printing of different conductive metals to try to create these multi-layers that are required for small and high performance printed circuits. So today, inkjet is typically unreliable, as well as screen printing, and dispensing and stencil printing seems to be the most reliable opportunities to move forward to create these vias to connect different layers in the multi-layer circuit board. I now want to move on to energy devices and focus on renewable energy harvesting. The clear thing I want to point out is there's no silver bullet. There's not one energy harvesting technology that's suitable for all applications, but we have a good opportunity for new solutions in various domains. I want to cover photovoltaic to piezoelectric. So we have to decide how much power and energy we need, as well as the voltage inputs. So photovoltaic or solar energy is great in direct sunlight, but of course for indoor applications, we drop down to around 10 microwatts per square centimeter. Triboelectric can produce very high power, but has sporadic voltage outputs, which means the conversion is complicated. Radio frequency harvesting is great because it's abundant, but the power is very sensitive on the distance, so it often requires the use of repeaters, which might be okay in healthcare settings, but not so much for remote sensing. You have thermoelectric, but for wearable devices, we only generate around 25 microwatts per square centimeter, and you need a temperature gradient to actually create any meaningful electricity. And then finally, piezoelectric, just 4 microwatts per square centimeter on body applications, but maybe more interesting for industrial applications. So looking at BFC, a paper-based energy solution, we use enzymes to convert sugar and oxygen into electricity, and we avoid the use of any metal in the stack up. So it's organic materials which can be composted, they're sustainable, we're using biological renewable catalysts, natural biofuels in sugar and oxygen, and we can produce milliwatts per square centimeter of peak power and milliwatt hour per square centimeter of energy, so useful for a wide range of applications. And where BFC steps in, we're solution agnostic, but we push our biofuel cell technology, combine it with wireless printed electronics, and then integrate different sensors and input-output such as Bluetooth transceivers or geopositioning with technologies like Sigfox to provide a value add. An example here on the right-hand side is a BFC printed circuit with NFC antenna and Bluetooth beaconing, and we can apply this technology into products such as logistics tech, health devices, luminous labels, agritech devices, as well as many other applications. One of the challenges is also the connection or links of the energy device to these printed circuits. Today, direct printing offers low design flexibility. You have traditional solder technologies, but it requires metallic battery terminals. You have ultrasonic welding, which requires specific materials to be compliant. And then there's new technologies such as anisotropic conductive films or ACF, which can provide good sustainability, but often need specialized equipment and therefore high upfront costs. And the kind of preferred method today is rivets or staples, but this is adding a bulky material. And you can see on these images here an example of a staple, and below here we have a pressure applied ACF, and on the right hand side we have a heat-free ACF tape. Moving on, I wanted to talk about active components. So I mentioned in terms of the 4 key rules that the key aspect is to minimize the amount of active components on the device. These dominate the life cycle assessment based on their mass. For massive production between 100,000 units and 1 million units, leveraging commercial system on chips or system in packages is a great option. Once you reach the 1 to 5 million units, moving towards an application-specific integrated circuit is usually the best option. But I wanted to point out, and we're here from Pragmatic Semiconductor Next, that technologies such as FlexIC from Pragmatic show huge promise for a new generation of low cost and low impact solutions. To finish, I just wanted to present some free tools that are available. So for lifecycle assessment, you can use Footprint Calc. You put electronic component footprints in and you'll get a LCA. There's IDA Mat, which looks at more the material from the bottom up approach. And then you have Open LCA, which is a complex system. But once you get your head around, you can follow all of the different processes. And then it's important also to look at end of life. And there are some good tools out there, OECD Data Explorer, to look at country data and material shipping, etc. And then Recyclast that looks at recycling guidelines. So to summarize my presentation, we've looked at the importance of transient versus reusable devices decision at the offset, key lifecycle considerations and factors, opportunities in the device stack-up, and some free tools. So thank you very much. And if you have any questions, please feel free to add them to the chat. Thank you.
Thank you so much, Jules. Now, so we'll go with Fraunhofer, the famous German RTO, Heike Munch. You can go ahead, Heike, introduce yourself, and go with the presentation within 10-12 minutes. Thank you.
Yeah. Thank you, Yves. Hello to everyone. I hope it's working. Yeah, I think you can see my presentation, right? My name is Heike Munch. I'm working as a deputy head in the climate management at Fraunhofer, a newly founded department, founded in 2022, like 2 years ago. I want to say thank you for the organizers for the webinar. Thank you for the invitation. I'm happy to present some sustainable activities of Fraunhofer. And even though I know the chance is high that you all have at least heard about Fraunhofer, I still want to say a few words about our organization. For the ones who don't know it, completely, Fraunhofer Gesellschaft is one of the leading research organizations focusing on applied research. It is based in Germany, founded in 1949. So last year we had already our 75th birthday. And our mission is to focus on key future relevant technologies to bring the findings to the industry and to the business in a good or for the benefit of industry and society. As an example, it's not maybe it's a benefit of society, but at least we all know it and use it. It's one of the most famous technology developments of Fraunhofer. It's the MP3 format that we all know. I think I could mention this here. Yeah, well, with about 32,000 people at the moment, we run about 76 institutes and research units within Germany. We have business volume of 3.4 billion euros, which is mostly stemming from industrial contracts and publicly funded research projects, while as the another third is base funding from Germany's federal and state governments. As I said, we work together with industry and business, and here we are really active in a wide range from automotive, energy industry, also pharmaceuticals, construction industry, materials, and so on. And of course, also the semiconductor industry, electronic, microelectronic. One of our institutes, I think, is even part of this project, SusFE project. It's the Institute for Electronic Microsystems and Solid State Technology in Munich, EMFT. And yes, I want to speak about sustainability at Fraunhofer. And sustainability is a very important topic for our organization for years now already. We address it in all corporate areas. But of course, as a matter of fact, our core business, research and development, is the most significant for sustainable matters, as our mission is to find solutions to tackle the major society challenges. So I want to just give you some examples. I have, of course, a more brighter perspective, but I think it's maybe interesting for you anyhow. So one example is from the renewable energy research from our institute in Freiburg, the Institute for Solar Energy Systems. They developed, for example, the world's most efficient solar cell with an efficiency at 47.6%. Or another example is the concept that they developed that allows for simultaneous use of agricultural land for both food production on the one side and green power generation, PV power generation on the other. Another example addresses the healthcare sector. This is the development of new vaccine production, realized by these 3 institutes mentioned here. They use electro beams to eliminate pathogens instead of the so far used toxic chemicals. And this now allows for faster, environmentally friendly, and more efficient, less expensive vaccine production, which is increasingly important nowadays. And a third very interesting example is the development of sustainable construction material. Our Institute for Wood Research, the Wilhelm Claudius Institute, they realized to develop recycling concrete made from old concrete or demolition waste. They combine it with plant-based fibers, for example, to really have it reinforced and strengthened, and really works like concrete, but with less emissions or carbon intensity. They also developed a substitution to cement that is made from rice husk ash, for example. Cement is, as you all know, all very carbon intense, so we have an alternative here. This is to give you an example on what we do in a research way, but as I said before, our sustainability activities address all other areas as well, or actually the research or sustainable research fields kind of resulted in the question, what can we do besides the technology development? What is the impact of our operations, and like how much energy do we use actually, and how carbon intense is the operation? So that is why we developed an own carbon reduction strategy in our organization. So we proceeded here like all other corporations. We started with preparation of greenhouse gas balance in the year 2020. Then we formulated specific climate targets. We want to reach the net zero goal by 2045, the latest. And we derived, really specific reduction measures in order to reach these targets. And of course, we try to be transparent as much as possible, and also report about this in our annual reports and CSR reports. To give you an idea, I don't want to get too much into detail, but I want to say that we did actually implement a really comprehensive reduction strategy, and try to really integrate all necessary steps, creating structures, for example, finding responsible persons at the institutes and the headquarters in Munich, where the climate management is situated. We provide instruments, and we try to help the institutes to really implement the reduction projects, which are, for example, the usage of green electricity, the extension of PV, the usage of geothermal systems, heat pumps, and doing a lot in terms of energy efficiency. And while doing so, from setting the preparation or the balance sheet for the carbon accounting, as well as driving the reduction measures, we actually found new ideas and challenges that resulted in new developments of technologies or services. That one I want to say here, like when we did the first greenhouse gas balance or the first accounting, we had to tackle or to fight with missing data, with not comparable LCAs for special products. We know that for the reporting, we need to have a regular data, comparable data. We actually wanted to have it automated and digitalized, etc., which is really a great challenge, I think. And this is not only for us, but also for other customers and businesses out there. So this resulted actually in a way that many of our institutes further developed standards for life cycle assessment. They try to harmonize. They've collect more and more data to LCA assessment for services, compounds, products, and so on. And one part I want to mention is that we also kind of found out that we are not able yet to record or capture all the emissions that stem from climate impacting substances we use. As I said before, we are working together with microelectronic industry, so we have a lot of clean rooms as well, and we know that we use etching gases, etc., that all have an impact. And we started to find solutions to better measure them, to calculate them, and also now we are on the way to find solutions to try system, how to abate them, how to clean them, how to reduce them or substitute them with, for example, gases with a lower global warming potential. And these are all examples of how sustainable activities result in new development ideas. And I think the time is over, right, Eve? I don't hear you.
You are close to be over.
Okay,
you can just conclude at this stage.
Okay, then what I want to say, the other slides you can maybe see in the other words is just more into detail of LCA assessment, also what we do here in our research project to really address the topic of clean room gas on microelectronics production, and also the development of biochar as a potential carbon sink, because if we want to reach net zero, we know that we need some negative emissions technologies, and this also led to a project where we tried to use biochar production as a potential sink. And to close with my presentation, I just want to say that, I definitely think sustainable is a key driver, and it promotes both, the sustainability activities and our research led to the question of what can we do in our own operation. And this again came or resulted in new ideas for new products and developments. And if you want to know more, please free to contact me later on. Thank you for your attention. And let's see if you have any questions.
Thank you so much, Eike. And don't be shy, so populate the Q&A box. It is available on the Teams toolbar, so don't hesitate, because we'll take them in 10 minutes from now. So the last speakers, but not the least, is Feras Al-Halil from Pragmatic Semiconductor. And Feras, introduce yourself and take the time to introduce Pragmatic and the sustainability option for your Flex IC technologies. Feras, go ahead. Thank you so much.
Thank you for the invitation and the opportunity to talk today. Hopefully you can see my screen properly. It's a very nice progression through the discussions that I started at this point. So I'm very happy to talk to you about Pragmatic in the context of sustainability. It's a core pillar for our proposition, for our development, for our future as well. So very pleased to talk to you in this forum today. So actually, a nice starting forum was where Heikki left, is on the topic of sustainability in the context of semiconductors. So these themes, I'm sure everyone is familiar with. They're sort of over the past few years and continues over the next few. There's a perfect storm of supply chain issues, geopolitics, skills, and sustainability. And the problem is that they're all driving different directions. So if you want to fix supply chains, you need to increase capacities, which goes against sustainability, goes against the way that sort of the supply chains are set up and so on. We believe sustainability is to the core of all of that, and actually it's the main driver. And the main challenge there is around actually some of the details that were mentioned just there, is that most of the work and the effort is dedicated to doing incremental improvements in for example, gases and chemicals and waste, introducing green energy sources for the complex manufacturing systems and environments. All of that is important, and of course, all of that is key. But ultimately, it only scratches the surface in terms of what we all aspire to in creating this step change in sustainability, while still continuing to drive innovation, technology adoption, digitization, and the like. I liked what Jules mentioned earlier, and I'll borrow that here, is that's where the challenge is, but it's also where we identify the opportunity is how do you create a step change in electronics sort of environmental impact while also driving for scale, driving for functionality, driving for things like form factor, and so on and so forth. So, and of course, our technology is unique to that. There's other emerging technologies like the one that Jules mentioned, but also wider emerging electronics trends that actually are quite unique in this space. So with that, I'm happy to introduce Pragmatic to everyone. Hopefully, most of you are familiar with us. For you that haven't, Pragmatic was founded in 2010. We're a UK-based semiconductor manufacturing company, world leader in ultra-cost flexible electronics. We call them Flex ICs. There's about more than 300 of us, close to 350 now. We have 2 sites in the UK, one in Cambridge, where we have our head office, and we have our manufacturing and R&D based in the Northeast. That's where I speak to you today from Durham in the UK. We have a variety of investors over the years. Some of the key ones from the early days are ARM and Avery Dennison. ARM around our applications for kind of computing. We've done a number of demonstrations that Avery Dennison around our applications for radio frequency identification. Since then, we've kind of positioned ourselves across how technology can meet supply chain issues, how we can create secure manufacturing, how we can reduce, of course, environmental impact in the electronics industry. So our vision is to empower innovation that connects digital and physical worlds with a sustainable core to all of that, because that we believe that's only possible to do with a sustainable platform and approach, because we're not talking about millions and billions of kind of items and objects and sort of applications. We're talking about trillions and tens of. How we plan to do that and how we're working to do that is by developing this unique flexible electronic platform at scale, and then working with our customers globally to enable the growth and adoption of their technologies. So our technology is an enabling platform in a similar way to how it was presented earlier. You can see an application like smart patches, for example. Our role in this is to bring the integrate circuits functionality, application-specific digital analog to support those functions with the right scale, right sustainability, as well as unique kind of properties like lightweight and form factor and so on and so forth. So I'll skip through for time through the kind of the wider context. This is digital transformation space. This is Internet of Things. The opportunity spans multiple sectors, from consumer to healthcare to transportation, smart manufacturing, etc. It's a very large opportunity, and we're basically in the early days of that in terms of wide adoption and sort of commercialization. What this looks like in terms of if you take a certain view across AI and advanced computation and where we're across the board, we are talking about kind of 3 sectors around cloud, edge, and item. And for cloud to reach its full potential, and you need to drive platforms and technologies across all those sectors. And where we come in with our technology specifically is across the item level all the way to edge, in the sense of enabling connect functionality, enabling sense functionality, enabling interaction functionality. Again, in exactly the same ways described earlier, you can have a smart system that can harvest energy, that can connect to physical sensors that can tell you temperature, humidity, certain properties. It can then do computation on board. It can interact with other system, it can feedback information outwards. And of course, the more you add to it, the more functionality you can look at smart system with significant complexity that can be deployed at this scale and this low environmental footprint that otherwise would be possible with conventional electronics. Another kind of key examples where actually it's not only a commercial story, it's not a commercial pure play, of course, but actually from a environmental and a global challenge perspective, for you to really make a scratch in terms of enabling reduction in food waste with smart packaging, or a different way of approaching these kind of challenges, to reducing waste in the sort of clothes industry, to enabling personalized healthcare, as was discussed earlier, at home, at low cost, at developing environment countries. You really need that step change and different approach in viewing this. So these are kind of we see them are kind of the near future opportunities that we're already working very hard on. You can see that expanded to beyond in a similar way, again, to what mentioned before, where you are looking about lab on chip applications that are not that are inherently and intrinsically sustainable in the way they're manufactured and the way they're deployed in their end of life application. And of course, what we bring to this is, of course, the cost point that enabled this ubiquitous use case and democratized approach to it. More advanced applications like sensor swarms, AR, VR applications, where actually the unique form factor of these technologies, flexible electronics in general, plastic-based, paper-based electronics, then are well suited for this from their unique form factor, lightweight, and so on. Now to go a bit more in detail on a technical front of why is this sustainable? Why is this different? The top line shows you a typical route for conventional silicon electronics in terms of how they're manufactured. Silicon chips starts from some silica. You then forming this into a high purity ingots, a high purity crystal material that you then use to post-process. So the snapshot, of course, is just how you generate the silicon wafer in this example. But if that continues across the whole complex and long processing sequence that happens for a silicon product, where you are dealing with temperatures in excess of 1,000 degrees, you're dealing with multiple steps of chemicals and solvents and acids and vacuum environment and high temperature processes and so on and so forth. So by default, the more complexity you drive in this, the more demand you put on this kind of flow, you're actually increasing the environmental impact significantly and exponentially in a sense at times. So the approach here we're proposing with flexible electronics is a paradigm shift in the way that we're creating this functionality. So you imagine a chip with an identical function that you create without going above 300, 400 degrees. So you've reduced that energy costs significantly. You've reduced that impact in terms of water requirements, etc., all the way down. Couple that with the process that's got customized and optimized to reduce use of harmful chemicals and gases and so on, so way that you're actually stripping all of those sort of added complexity out of the system to get the simplest way. Of course, it still has an environmental impact, but compared to a silicon or conventional solution of the same functionality, there's a significant difference in the environmental footprint in that. And how we do that here is a snapshot of how the substrate preparation happens. We have recyclable substrates that we use, carriers. We use for mechanical sort of support, but actually the functional stack is built on a polymer that's dispensed on these materials and is cured at low temperature, relatively low temperatures. And then you build your device stack on top of that, and at the end you release it from the carrier and you reuse the carrier through your line. So you're kind of customizing, reducing your footprint, and to the point of polymer as well use, of course, that's a factor, but we're able to optimize that to the lowest point possible, where it has an impact on the cost, but also the environmental impact is then reduced from this material. And as more innovations, and we're always keen on driving that, as more innovation happens on the polymer front, we would bring that in, and you can see that actually working. It's purely compatible with the approach we have, where we can bring more and more of these more sustainable green material to replace the parts of the process that relies on polymers, for example. The other aspect in all this, of course, you made the manufacturing, the supply chains right now look like this as a snapshot, essentially, just to highlight where to make a product, you have to manufacture in a fab in some place. You then have to send it out for packaging assembly. You have to assemble it in a smart system. You have to test it elsewhere. The supply chains are very complex across the world. That's part of the geopolitics angle to it, of course, but actually from a sustainable environmental perspective, it's a big factor as well, in the sense of just the back and forth that happens across different facilities and different sites, and there's opportunities, of course, to streamline that from perspective of onshoring certain capabilities, and that's of course happening already. But actually, the simplification of what we're proposing here, of where you create a fit for function application, fit for function electronics deploy them in the right way, and actually then localize manufacturing to where it's needed across the world for any of these applications that happens. And that's intrinsic to technology and the approach we adopt here at Pragmatic. To summarize, this is what it looks like. This is what our technology offers. We're able to scale to billions of flex ICs, billions of items per manufacturing line. Each of those manufacturing lines is a compact footprint in 600 meter square, footprint that can be deployed anywhere around the world. You're talking about cycle time from raw materials to completed flex ICs in about 48 hours. We're able to bring in designs from customers through a foundry route in about 3 to 4 weeks cycle time, allowing new designs to be iterated at a much higher turnaround time in a more agile way to be able to drive innovation. And ultimately, this solution can be done at a step change in costs compared to conventional solutions. And more importantly, from a sustainable perspective, you're using significantly lower resources to create the same function, and you're able to also scale it in a similar way where you are no longer compromising any you're able to kind of break through this kind of compounding factors around driving innovation, driving digitalization, while also risking, seriously risking sustainability aspect across multiple sectors. And with that, I would say thank you. If you have any questions, I'm happy to take them now. And thank you again for your time.
Thank you so much. Thank you for all speakers. It is now the turn to raise questions. So the chat box is void, but I have a lot of questions. So maybe I can start with one, particularly for the companies, but also Heike can answer. One is, okay, sustainability is a good option because we speak more and more about sustainability. The regulation in Europe is increasing, has been updated, and we have new incentives, not probably so much for healthcare now, but for other industries. And you are serving, you all, except Capitainer, but Fraunhofer, BFC, and Pragmatic Semiconductor, other industries, and not only healthcare. But how sustainability can be cost-effective as well option? It is good to be sustainable, but at which expense? Can you elaborate on it? And including Christopher as well. Quickly, concisely.
So very fast, one of the applications that BFC has been working on is smart labels for logistics applications. And the two companies we've partnered with is DS Smith and Avery Dennison. And a key point here is the return logistics of traditional battery-powered tags can be up to 60% of the cost of ownership. So with BFC technology, we have a compostable energy device, with the energy device being the most environmental impact in an electronic product. And therefore, the cost of disposing versus the cost of collection, returning, processing, sorting, and recycling is overcome with our technology. So that's one clear example.
I can add to that from a manufacturing perspective. We almost see them as equal. So we're driving our sort of Flex IC environmental footprint and around the same roadmap of our cost reduction as well, because it's cost reduction in the material usage and the processing conditions, so on and so forth. So because it's foundational to technology, it's the same driver. So for us to reduce cost of the solutions we offer, adoption, the growth of those solutions, and the scaling of it, it goes hand in hand with the driver. With driving sustainability as well.
Yeah, I can just agree with the previous speakers. We have very much the same thing, especially looking at the transportation. I saw one slide that was really funny about how the products was jumping all over the place. We definitely see it as a major issue and something we really work with. And in truth, it's actually not cannibalism, and we save money by really trying to dig down into the sustainability. So that project is actually leading to cost reductions. So we see it as a positive, not only as something for our customers, it's actually for ourselves as well.
Yeah. I mean, I can just add that at Fraunhofer, it's very complex, very heterogeneous. I mean, there are so many different topics that we address and we work on and do research with and have customers we work with. So it's both. It's sometimes, especially when it comes to the carbon reduction within the next years, we already have resulted equipments, but the really hard part is yet to come. It will cost us something, of course, but on the other side, as I try to make clear, is that we also see a very big potential in finding new ideas, new technologies. Also, it is a task, a responsibility that we all have to do. We are based on the planet and we need to secure the natural resources, and our customers ask for it, and we need to have some ideas and solutions for it.
Thank you. I have another question about sustainability. What is the most important in terms of communication? It is upstream, so what you can do, you as manufacturers and all developers, so it means sourcing the material, designing the solution, and or downstream sustainability, so anything coming out after the manufacturing and then the adoption of the products by users. So and then the fate in terms of recycling, reuse, and whatever. So what is the most important at this stage, and where you are, the most comfortable to communicate?
Okay, so I think it's actually quite complicated to communicate because actually lots of great companies that are doing great things are now being attacked for essentially greenwashing. So I think this is actually a greenwashing from companies that don't have any real interest in sustainability is causing a huge problem for lots of companies that are putting it as one of the core values. Then to your first question, for me, it's trying to sit down with customers and stakeholders and understand how products will actually be used. Because if you don't try to inspect the full chain, you can easily miss one thing like distribution or one thing like end of life or it's all well and good to try to design something that can be recycled through 3 different recycling centers, but if someone just puts it into the household waste, it never sees that. And if your entire life cycle assessment is dependent on the recycling, actually a traditional product could actually be a better solution. So understanding the use case is very important at all stages of its life.
Yeah, I can go. We as we are selling, focusing on the healthcare market, this is actually a very tricky question. We believe this will probably be one of our strongest unique selling points we have from Capitainer, even though we have a lot of other technology as well. But the problem is that the customer base has not started to work on it because it's not mandatory yet for healthcare, which means they're doing nothing. And we haven't even seen it. We're starting to see it in a few tenants in UK. We started to see more and more coming up as a demands, but not on the actual work. So what we're doing is right now is just cleaning up our own house. That's why I said, yes, we started, but we are not complete on our own. We need to make sure we have a full plan with actions and goals and follow up. But we are preparing a lot in terms of how we will talk with the customers about that, because when it hits them the same way like IVDR, they will be in panic to do something. And then it's very important for us to not only have our own things done, but also to use it from a selling point of view.
Any other quick comment on this topic? It's not an easy one, huh?
Yeah, I would agree. It's a complex picture. What I would say is certainly it's more of a core topic for discussion now than ever it's been, which is certainly the right way. I think to Christopher's point, there's aspects of regulatory kind of that has to come into this, because it's all well and good to talk about it and explore it, but actually till you have boundaries to work with and targets to meet, then you actually see a paradigm shift there. but for us, it's been core to every discussion we're having, translating it down to customer, and sort of a product lifecycle, as Jules said, is of course also key. That's a bigger and a more complex value chain, clearly. So we're at the start of the journey in kind of certain ways, but what I see we're doing and what I saw today is actually it's where we're more ahead, which is where we're already kind of creating a path there across sort of innovation and sustainability, where it's core to the foundations of what we do, and that fills me with optimism for sure.
Like a quick comment, you are not obliged, huh? And before closing the webinar?
I totally agree. It's complex. It's important. I think transparency is important. Also to say what you are not good at yet, and that you're started your way, and that you're really trying, and also to openly communicate about the weak parts. I think that makes you stronger in the end.
Thank you so much. Thank you for all people having attended. So we should be in touch. Maybe people also may reach out to you later on. If you are keen to share your presentation, then we can upload them on our SusFE website, and then to have some communication by using X, LinkedIn, and the other channels to refer to those presentation, and then as well to use your LinkedIn profile to ask any other question coming later, and not to be raised publicly, but to be raised on a one-on-one fashion. Thank you so much. Enjoy the rest of your time. You speakers, it was a pleasure to hear from you about sustainability as a key driver, and you as well attendees. Thank you so much. Bye-bye.
Thank you.
Thanks, everyone.
Bye.
It's been a pleasure. Thank you.
you.
Bye-bye.